Today our lesson is work. Okay, so everyone knows what is work. So before starting our lesson, I would like to ask you one question. What happens when we do a lot of work? Obviously, the answer will be we get tired. When we do a lot of work, we get tired. I'll give you a few examples out here. Look at this person working in office. A person is just sitting in front of his PC and is doing some work. Okay, and looking at him, we can feel that he is getting really tired. So he must be doing some work, isn't it? Sometimes students does a lot of homework and they have to study a lot. They tend to get tired. Sometimes teachers, they have to correct the copies whole day. Okay, and what will they say? We are tired because we have done a lot of work. Okay? But this kind of work is not defined by physics. Physics does not define this kind of work. This kind of work, we can say it is a mental work. Okay, we get exhausted though, but this kind of work are called mental work and it is not defined by physics. So for work to be defined by physics, there are two things necessary. Number one is force and number two is displacement. Okay, look at this. Here the ball is being kicked by a footballer. The footballer is applying force on a ball and the ball is being displaced. Out here the work is being done because the force is displacing the ball. Another example you can take, carrying a load and walking upstairs. Okay, those are example of work because we are applying the force on load and we are displacing it. Okay, now let us define work. Work is said to be done when force produces some displacement. The definition of work is said to be done when force produces some displacement. Look at this example. The work is being done because the force is producing some displacement out here. Okay. Numerically the definition will be numerically the definition will be work done is the product of force and displacement. So we'll have the formula for work. W equals to F into S. This is the formula for work. W equals to F into S, where F is force and S is displacement. Okay, F is force, S is displacement. Keep in mind, S is not speed but S is displacement. So W equals to F into S is the formula for work. We will need this formula while doing numericals. Okay. What are the conditions for the work to be done? Okay, there are few conditions which the work has to fulfill to be done. Number one, okay, force should be applied. Number two, body should be displacement. The conditions necessary for work to be done are force and displacement. There should be force, there should be displacement, then only the work will be done. Okay. Our next topic will be, what are the conditions for no work? Sometimes the work is not done even though there may be force or even though there may be displacement. Okay, so what are the conditions when no work is being done? Number one, when there is no force. Since work done equals to F into S, work done equals to F into S, if F is 0, 0 into S will be 0, so there will be no work, therefore work done is 0. So this is one example of no work. One example of no work will be when force is 0 or when there is no force, there is no work. Number two, when there is no displacement. Just now we wrote W equals to F into S. Now there is force but there is no displacement. F into 0 is 0, so there is no there is no work because there is no displacement. Okay, can we write some examples where there is no displacement? Number one, look at this person pushing at the wall. This person is pushing the wall. Okay, this person is pushing the wall, but the wall is not being moved. Even though he is applying a lot of force and he is getting really tired, but he's not doing any work because he is not producing any displacement. Look at this wall. Is it moving? No. Another example is a person carrying a brick out there. A person is carrying a lot of brick on his head, but he is not moving. If he stands like this whole day, this person will get really tired because he's carrying a lot of load or weight. But why he's not doing any work? He is not doing any work because he is not moving. Look at this person. He is not moving, and look at this wall. It is also not moving. Though there is a lot of force, okay? He has to apply a lot of effort to hold this brick, and this person is applying a lot of force to this wall, okay? But in both the cases there is no work because there is no displacement, okay? Now next condition is when the force and displacement are at 90 degree. Suppose this is the force, okay, suppose this is the force and this is the displacement. What is the angle between them now? The angle is 90 degree. If there is a condition like this, then the work done will be 0. We'll learn about this in detail in higher classes, but for the time being, you just understand when the force and displacement are at 90 degree, the work done is 0. I'll give you a few examples. Look at this example number 1. Out here, the person is moving in a horizontal platform, okay? The displacement is along x-axis, the force is along y-axis because he is lifting the load up, okay? And he is lifting the load against the force of gravity. This is the force of gravity. This is the force of gravity. He is lifting the load against the force of gravity in vertically upward direction, okay? So in this case, force and displacement is at 90 degree, so there is no work. Another example, look at the earth revolving around the sun, okay? The force by the sun towards the earth is in this direction. The earth will be attracted by sun in this direction, and the displacement for the earth is this position. So the angle between force and displacement will be, this is force, this is displacement. So the angle between them is 90 degree. So in this case also the work done is 0. As I said earlier, in details we will learn this in higher classes, but for the timing, what we should understand if the force and displacement are at 90 degree, the work done is 0. You'll be asked to write down few examples when there is no work. You can say a person carrying a bag and walking in a horizontal platform, or you can also say revolution of earth around the sun, or you can also say movement of moon around the earth, okay? In all these cases no work is being done. All right, so what is the unit of work? SI unit of work is joule and CGS unit is arc. We have to learn this. Now one numerical question for practice. A boy applies a force of 200 Newton to displace a table by 10 meter. Calculate the work done. Okay, so first of all, after understanding the problem, we need to write down given. The given is if force is 20 Newton, Newton is the unit of force, displacement S is 10 meter. Okay, after writing force and displacement, we need to understand what we have to find out. What we have to find out? We have to find out work done. So let's write down the working formula for work done. We know W equals to F into S. Okay, we know W equals to F into S. Or now let's put the value. W equals to F force is 20 Newton, S displacement is 10 meter. We have put the value for F and S, 20 into 10. Okay, multiply this, we will get 200. Therefore W equals to 200. Unit is joule, so I have written out here J. Thus the work done is 200 joule. We have to write in at the end. Okay, thus the work done is 200 joule.